Hi, Ms. Barber here. This lesson is titled Implicit Differentiation. Consider the function 7x minus x squared minus y equals 3x minus 2y. Find dy dx. That's the derivative of y with respect to x. To find the derivative, we first solve for y. Let's get all the terms that are y on the left-hand side, all the terms that are not on the right-hand side. So we'll add the negative 2y to both sides. On the left side, we'll get negative y plus 2y. And on the right-hand side, the 3x stays put. We have a minus 7x and plus x squared. Now let's combine the terms. Negative y plus 2y would be y. And 3x minus 7x is negative 4x. We still have the plus x squared. We can now differentiate. We get the derivative of y is dy dx, and the derivative of negative 4x is negative 4, plus the derivative of x squared is 2x. Now consider the function 7xy minus x squared minus 3x times y squared equals 9. To find the derivative, we need to solve for y. This would be difficult, if not impossible, algebraically. Implicit differentiation allows us to obtain derivatives without first solving for y. Before we proceed to implicit differentiation, let's revisit the chain rule, and we will extend that process to implicit differentiation. For example, d dx of x, that means take the derivative with respect to x, and that's equal to y. However, if you do d dx of y, remember y is that outside function, it's y of x. The derivative of y, that constant is 1, but you still need to multiply it by the derivative of the inside function. Since we don't know what that inside function is explicitly, we just say dy dx. So that would be equal to the derivative of y, which was 1, times y prime. That product is y prime. Now let's look at d dx of x squared. That derivative is 2x. Let's try it with the y squared. d dx of y squared is equal to, the derivative of y squared is 2y, but then you need to multiply it to the derivative of the inside function, and that derivative of y is dy dx. You can also write that as 2y times y prime, which is 2y y prime. Notice what's happening here. Every time you take the derivative of y, the outside function, you multiply it by y prime, the derivative. Reminder, y prime and dy dx are two different notations that both represent the derivative of the function y. Example, find y prime for y to the 5th equals x. Let's do this by implicit differentiation first. So what we want is the derivative with respect to x of y to the 5th equal to the derivative with respect to x of x. Implicit differentiation, when we take the derivative, we bring the 5 down. Y to the subtract 1 is 4. The thing to remember with implicit differentiation is every time you take the derivative of y, multiply it by the derivative, y prime or dy dx, whichever you prefer. And the derivative with respect to x, that's just 1. Since we're looking for the derivative, we need to isolate the y prime. So y prime is equal to 1 divided by 5y to the 4th. What if I want my answer all in terms of x? Can I do it here? If you have y to the fifth equals x, oh, look at that. I can take the fifth root of both sides. So y is equal to x to the 1/5. Y and x to the 1/5 are same things. So we could have y prime is equal to 1/5 y to the 4th, and where the y is, put in x to the 1/5. Simplify those exponents. Y prime is equal to 1/5 times the fifth root of x to the 4th. Couldn't we have just done that directly? Let's see. Take the derivative of d dx of y, that's what we always do, or we have been doing, and d dx of x to the 1/5. The derivative of y is just y prime, and the derivative of x, bring the 1/5 down. You got x to the power of 1/5 minus 1, would be minus 4/5. Rewrite that without a negative exponent, and you get y prime is equal to 1/5, the fifth root of x to the 4th. Exact same thing as before when we did it with implicit differentiation. And so the question is, why did we have to learn implicit differentiation? So glad you asked. Let's do it in this example. Find dy dx for x squared plus y squared equals 1. So we need to take the derivative with respect to x of x squared, add it to the derivative with respect to x of y squared is equal to the derivative d dx with respect to x of 1. The derivative of x squared, bring the 2 down, and it's x. The derivative of y squared, bring the 2 down, y, but when you take the derivative of y, always multiply it by the derivative y prime. And the derivative of 1 is 0. We are isolating, we want the dy dx. So I've got 2y times y prime is equal to, subtracting 2x from both sides, minus 2x. Now divide by 2y on both sides, and I get y prime is equal to minus 2x divided by 2y. The 2's are common, and so I've got y prime is equal to negative x over y. However, the problem said find dy dx, so instead of using the y prime notation, use dy dx is equal to minus x divided by y. Example. Find an equation for the tangent line to y to the 4th plus xy equals x cubed minus x plus 2 at the point 1, 1. In order to get the equation of a line, you need 3 pieces of information. You need a point, which is given in the statement of the problem. We also need the slope, which we will compute. Slope m is the derivative dy dx, and we want it at that specific point 1, 1. That's where it's going to be tangent to, and we need some form of an equation of a line. So let's find the derivative by implicit differentiation first. So we will take the derivative d dx of the term y to the 4th plus d dx, that's the derivative with respect to x, of the product x times y is equal to d dx of the term x cubed minus d dx of x plus d dx of 2. Taking the derivative of y to the fourth. Bring the 4 down. Y to the 1 power less is 3. When you take the derivative of y, you need to multiply it to the derivative of the inside function. You can use dy dx or y prime. They both mean the same thing. Next, we need to find the derivative of the product of x and y. So we'll use the product rule, and we'll have the first function, its derivative, x's derivative is 1, times the second function, y, plus, then we'll have the first function times the derivative of y. The derivative of y is 1, but every time you take the derivative of y, you have to multiply it to the derivative of the inside function, dy dx. The derivative of x cubed, bring the 3 down, x and 1 power less than the exponent would be 2, minus the derivative of x is 1, and it's not necessary at all for you to write that the derivative of the constant 2 is 0. From here, our task becomes algebraic. So I will have 4y cubed times dy dx plus y plus x times dy dx is equal to 3x squared minus 1. We need to isolate the dy dx. So on the left-hand side, let's have the 4y cubed dy dx next to the x dy dx is equal to, the right-hand side still has the 3x squared minus 1. Then we need to subtract the y from the left-hand side, so you get minus y. I'm on a new slide now, so I'll copy the last line from the previous one. That's 4y cubed dy dx plus x times dy dx equals 3x squared minus 1 minus y. Let's factor out the common dy dx on the left-hand side. Then you get dy dx. On the first term, you have 4y cubed remaining. On the next one, you have x remaining. That's equal to 3x squared minus 1 minus y. Now divide the 4y cubed plus x from both sides, and we get that the derivative dy dx is equal to 3x squared minus 1 minus y divided by the entirety of 4y cubed plus x. Now we need to put in the values of the ordered pair 1, 1 in order to solve for the actual slope at that point. So the slope is dy dx evaluated at 1, 1. In the derivative function, put in the values. You'll have 3. Where the x was, put in 1. So 1 squared minus 1 minus y is also 1 divided by 4 times, put in 1 for the y cubed plus 1. Solving this, you'll get that the slope is equal to 3 minus 1, that's 1 in the numerator. 4 plus 1 is 5. Now we are ready to get the equation of the line. For the equation of the line, I'll use the point slope form. Y minus y1 equals m times x minus x1. We have that the y1 value is 1. The slope we just solved for is 1/5 x minus 1. Now solve for the y. Y minus 1 is equal to 1/5 x minus 1/5. And so y is equal to 1/5 x. That gives you positive 4/5 for the y-intercept. Example, find the second derivative d squared y over dx squared in terms of x and y for sine x plus cosine y equals 1. This one needs to be solved by implicit differentiation as well. So let's begin by writing d dx of sine x plus d dx. Remember, d dx means derivative with respect to x of cosine y equals d dx of 1. We'll use our trig derivative formulas. The derivative of sine is positive cosine x. The derivative of cosine is minus sine y. And we need to take the derivative of the inside function. So for the derivative of y, we can write dy dx. And the derivative of the constant 1 is 0. We can write this negative sine y. Let's make that look more like a y. dy dx is equal to, subtracting the cosine from both sides, minus cosine x. Isolating the dy dx, you got minus cosine x divided by minus sine y. So the derivative dy dx, the first derivative, is the cosine of x divided by the sine of y. The first derivative was dy dx equals cosine x divided by sine y. We want to get to the second derivative, so to do that, we're going to take the derivative with respect to x of the left-hand side dy dx and the derivative d dx, so with respect to x, of the right-hand side cosine x divided by sine y. The second derivative we write as d squared y dx squared. Now we'll need to use the quotient rule to take the derivative of cosine x over sine y. Remember the quotient rule. If you have a ratio of two functions, high over low, then that derivative is the denominator squared, and numerator is low d high, that's low times the derivative of the high, minus high d low, high function times the derivative of the low function. Applying that, we'll square the denominator, so you got sine squared y. And in the numerator, we write the low function which is sine y, and multiply it to the derivative of cosine, which is minus sine, and it's with respect to x, minus. Then we write the high function, which is cosine x, and then we take the derivative of sine y, that would be cosine y, and when you take the derivative of y, you have to multiply it by dy dx. dy dx is cosine x divided by sine y. Let's replace that. You will have minus sine x sine y minus cosine x cosine y times the dy dx, which is cosine x divided by sine y, and the denominator sine squared y. We need to algebraically multiply out that sine y. Quick way to do that is to multiply the numerator and the denominator both by sine y. Distributing. We're going to take the sine y and multiply it to minus sine x sine y. That would give us minus sine x sine squared y, and then distribute that sine y to the second term. That'll end up canceling the sine y's, and so now you'll have cosine squared x cosine y, and all of that will be divided by the product of sine squared y times sine y, which would be sine cubed y. So d squared y dx squared is equal to, in the numerator, negative sine x times sine squared y minus cosine squared x times cosine y divided by, in the denominator, sine cubed y.